Hello friends, welcome to a new algorithm of data science, machine learning. This is very interesting algorithm of all the machine learning algorithms here, that is artificial neural network. The part of human inspired computing, this algorithm has become very useful, effective, and in terms of accuracy also, this is very regularly used in the machine learning. And because of this algorithms, neural network algorithms, the rise of new technique called as deep learning is there in the advanced machine learning techniques. So let's try to understand first what do you mean by artificial neural network. Okay, so neural networks, so human is having ability to identify patterns within the accessible information with an astonishingly high degree of accuracy. Whenever you see a car or bicycle, you can immediately recognize what they are. This is because we have learned over a period of time how car and bicycle looks like and what their distinguishing features are. ANN, artificial neural network, are computation systems that intend to imitate human learning capabilities via a complex architecture that resembles the human nervous system as it is. Let's understand the human nervous system. So we are having a brain, and that brain is made up of such billions of neurons present in our brain. Now these neurons are used to process the elements, process the data that we are taking from 5 input devices. Yeah, human's body is having 5 input devices, so 5 senses from which we take the inputs, and this neuron processes this data. How? So neurons contains, these are the dendrites. Dendrites are receiving the information from either sensory organs or the previous neurons. Okay, it processes that data with the help of this nucleus, and then whatever you have learned, that learned things will be passed to the next level of neurons with the help of axon. Okay, axons. This is axon layer, and these are called as axon terminals. Axon terminals are now connected to the next neurons, dendrites, that will take the information, again processes that and passes to the next neuron. So this human nervous system, whatever I explained, so exactly in the same way we can create a replica of it in the form of a network of neurons, that's called as artificial neural network. Okay, so dendrite, nucleus, and axons, these three are the main important part that this human nervous system contains internally. Now this neuron we convert in the form of a computer created neuron, that we call as the perceptron. Artificial neural network are inspired by the human neural network architecture. The simplest neural network architecture of only one neuron is called as perceptron from the computing point of view. Now where we have these input devices, input things, okay, input features x1, x2, x3 till xn, and then all they are given to this processing element. Okay, here processing element summation is done. w1, 2, 3 till wn are the weights which are adjusted automatically, or they are multiplied with this number, and then the summation is generated here. We are having activation function something like this, w of 0t is equal to theta. This is the activation function, and based on activation function, operation is performed on this data, and then we are going to generate some results out of it, that is out of t. This is a single neuron, and that we call as a perceptron from computer's point of view. Now how perceptron works? So perceptron has one input layer and one neuron. Input layer acts as a dendrites and responsible for receiving the inputs. The number of nodes in the input layer is equal to the number of features in the input data set. Make sure the number of input layer is equal to number of features in the data sets. Every feature is given to one layer of it. Okay, each input is multiplied with the weight, typically which is typically initialized with some random value, and the results are added together by summation. Fine. The sum is then passed through an activation function. The activation function of perceptron resembles the nucleus of human nervous system. So human nervous system is having activation function. Based on that, you extract the information and you pass it through the next layer. Okay, so here we have that activation function also. It processes the information and yields an output. In case of a perceptron, this output is the final outcome. Okay, single layer perceptron. However, in case of multi-layer perceptron, that is MLP, the output from the neuron in the previous layer serves as the input to the neurons of the preceding layer, and then it will pass information from first layer to second layer to third layer, third to fourth, and so on till the last output layer has not reached. Okay, so what is artificial neural network is? The multi-layer perceptron is commonly known as the artificial neural network. Single layer perceptron can solve simple problems where data is linearly separable into n dimensions, where n is the number of features in the data set. However, in case of non-linearly separable data, the accuracy of single layer perceptron decreases significantly. The multi-layer perceptron, on the other hand, can work efficiently with non-linearly separable data also. Okay, correct. And artificial neural network are combination of multiple neurons connected in the form of a network. It has an input layer, one or more hidden layers, and an output layers. Okay, so this is what ANN actually made up of. Check it out. This is inputs. Now this is input layers, and 3 input layers we have. Hidden layer, so we have 4 hidden layers here. Okay, and output we have 2. So see, output and input is created by the algorithm. Hidden layers will decide by ourselves. Okay, so how to number of features, whatever number of features are there for this particular neural network, we have 3 input features. Okay, so 3 features I am providing as input, and 2 classes are there as the output. That's why 2 layers are there at the output. Hidden, we can have any number of nodes, any number of such parallel hidden layers are possible. So here in this single layer we have 4 nodes, something, so we can have multiple 4, 5, 6, 7, 10, hundreds of layers are possible within that. So artificial neural network is just one of the implementation of the neural network present inside the human brain. So how actually it works? So theoretically we'll see, and they will show one classical example by practical implementations of it. Okay, so 2 phases are there in ANN. They are called as feed forward and the back propagation. So what is feed forward? The values received from the input layer are multiplied with the weights. A bias is added to the summation of inputs in order to avoid the null values. Okay, then each neuron in the first hidden layer receives the different values from the input layer depending upon the weights and bias. The neuron have an activation function that operates upon the value received from the input layer. Okay, the activation function can be of many types, like step function, sigmoid function, ReLU function, tanh function. These functions contain their formulas. It will work on that formulas, and the resultant value is passed to the next layer. As a rule of thumb, ReLU is the function used in the hidden layer neurons, and sigmoid function is used in the output layer neurons. The output from the first hidden layer neuron are multiplied with the weights of the second hidden layer as the result of sum together and passed to the neurons of the preceding layer. This process continues until the outer layer is reached. The values calculated in the outer layer are called as actual output of the algorithm. So this is what we call as feed forward phase and feed forward neural network. Okay. Feed forward phase consists of basically 3 steps are there. However, the predicted output is not necessarily correct in the right way. It can be wrong also. So we need to correct it. The purpose of learning algorithm is to make predictions that are accurate as possible. To improve these predicted results, a neural network will then go through a back propagation phase. During the back propagation, the weights of different neurons are updated in a way that the difference between the expected desired output and the predicted output is as small as possible. So we are going to make this difference as small as possible with the help of the second phase that we call as back propagation. So in back propagation, the result generated will come back again. The error is then calculated by quantifying the difference between the predicted output and the desired output. So error will be there, obviously. This is what we call as a loss, and the function used to calculate the difference is called as a loss function. This loss function can be of different types, like mean squared error function or cross entropy functions, which are used to identify the loss between predicted output and expected output. Remember, neural networks are supervised learning algorithms that needs desired output for a given set of inputs, which is what allows to learn from the data. Now, what back propagation does? Once the error is calculated, next step is to minimize that error. To do so, partial derivative of error function is calculated with respect to all the weights and biases. This is called as gradient descent. Okay, so partial derivative of error function is calculated, it's called as gradient descent. The derivative can be used to find the slope of the error function. If the slope is positive, the value of weights can be reduced, or if the slope is negative, the value of weights can be increased. This reduces the overall error. The function that is used to reduce this error is called as optimization function. So feed forward passes the information from previous layer to next layer, and back propagation find the loss, and if not able to reduce the loss, weight will be adjusted so that the generated results will be passed back to the previous layer with the help of back propagation phase. And now what exactly? The cycle, one cycle of feed forward and the back propagation layer is called as one epoch. This process continues until reasonable accuracy is achieved. So the value of epoch can be specified by the user who create the neural network. There is no standard for reasonable accuracy. That ideally generally we try to identify 100% accuracy there, but this is extremely difficult to achieve for any non-trivial data set. In many cases 90% accuracy is considered acceptable, but it is really depend upon your use case. Okay, that's how the neural network theoretically works. Let's see an example. A good example I find in Friendly Introduction to RN by Luis Serrano. Let's go with this. Okay, so for example, I am living in a room. I want a perfect roommate. Okay, this roommate is a perfect cook also. So I want, or we want actually, the food from him. So he must be a cook, and he must be capable of cooking apple pie. He must be capable of cooking burger. He must be capable of cooking chicken. But the thing is that I got a roommate, but that roommate is cooking the things on conditions. On conditions. What's conditions are there? The conditions are when the outlook, okay, so when the day is sunny, he is cooking apple pie, and when the day is rainy, he is cooking burger. So these two things depends upon these two things. Fine. It is straight line dependency is there. Now this straight line dependency I can convert in the form of a neural network. Now how? Check it out. So my input is the environmental situation outlook. Neural network will take that input and will generate a result of the food. So my food, resultant food, is the apple pie when I am having the sunny environment here, and so on. Burger will be there when its rainy situation is present there. So neural network, how it will be created, that we'll see. Now a neural network assigns the vector array to respective data elements. Now consider I am expecting three outputs from there. Three outputs are, that's why I create a vector of three elements here, something like this. Apple pie will be represented by 100, burger will be represented by 010, and chicken will be represented by 001. Okay, so this vector will be assigned because three outputs are expected out of it. Actually I am not considering this one, which is we have preceded in the example, and my condition variables, that is my input variables, are this. So when sunny, I am connected to this. When I am rainy, it is connected to this. So sun, that is input variable sunny, only two input variables are there. That's why I am having two input layer for this case. So its value will be 10, then it's sunny, and value 01, it will be rain. So that's what the conversion of data will be done by the neural network here. And now let's formulate in mathematics. So I am having, when I am having this vector, my output is this, and similar to that, if I am 100, my output will be 10. Okay, so neural network conditions are something like this. And now let's add it. Now see, so how the neural network will be conceptualized. See this one. So I am having this as input, I must expect this as the output, and when I am having this as the input, I must expect this as the output. So how to do this one? Let's try that. So this mask is created by the neural network, which will be a perfect mask for this neural network here. So, and I am going to check it now. Now see, when my input is this, consider this one 01. So I will take this mask over here. So here this will be multiplied by the original input. So when I multiply this 100 and 010 with 01, I multiply that, and after this multiplication I will get this matrix. Okay, so this matrix which represents a burger. Okay, if you multiply this mask of neural network with the input, if you multiply them, I will get the output. Similar to that, if I use this mask to multiply this, I will get this apple pie. Okay, if I multiply this number by this matrix, or this vector by this matrix, I will get this. So that's how it's added. So conditional mask is generated here, and that will be assigned so that perfect output I will be generating out of it. Now let's see, this is how ANN is now formed for this kind of situation here. So Now converting it into ANN format. Let's have two inputs, two conditional variables we have here, correct? And three outputs are expected out of it. These are the three nodes in output layers. These are the input layer, this is the output layers. And now they are connected. Check it out. So which are shown in the bold color, they contain the one weight connected to it here and here, and which are in the gray color, so very light gray color, so they are connected with 0. So they are having weight as 0. Now let's see. For example, my input variable is now 1 0 1 0, and this layer will pass information to the next layer. So it will multiply these weights. 1 into 1 I'll have 1, 1 into 0 I'll have 0. Okay, so 0 into 1 again I'll have 0, so we'll add it together. This is also 0 into 0, I'm adding 1 plus 0, this is 0 plus 0, and here again 0 plus, from here also 0. I got 1 0 0. So input, when input is 1 0, I'm having 1 0 0. Okay, it means that when input is sunny, output is apple pie. Now if you try the same again on the second, like if I'm having 0 1 here, that is my outlook is rainy. So in that case, if I write 0 and 1 over here, let's look at that. So if I write 0 here, here it is 0, so this will become 0. So 0 is from here also it is 0, from here also it is 0, here also it is 0. Sorry, not this, from here, here, here and here, all this will be 0. And if it is 1, if this is 1, so I'll have this 1 here, this will be 0 and this will be 0, means output, when input is raining, then output will be 0 1 and 0, which will be outputting as a burger. So neural network is formed dynamically with the help of such conditions, and when the network is formed, then such layers will be added, weights are added, and based on that we are going to do the prediction. So here in this particular example, I have not shown the feed forward and back propagation phase, but this is only feed forward are shown. Back propagation will find the error in the expected output and will pass that information again back, and weight adjustment will be done, and again it will be forwarded. So these epochs are also present to make the neural network more and more accurate. But this is how it is simplified, how a neural network can be formed for the respective data set. Okay, so neural network formation is done. Now let's go for practical implementation of the network with the help of our algorithms. So we require pandas, numpy and scikit-learn for this data set. Okay, so let's go for the data set first. So I'll go to my web link here and I'll show my data set. So for this algorithm, I'll be using a very interesting data set here called as diverse predictor data set. What's the meaning of it? So let's see this. This is what we are having: a personal form, participant completed the personal information form, and diverse predictor scale is present there. Now a counselor is having almost 54 questions when a particular case is filed for divorce. Okay, so the counselor is giving a form and some questions are put onto that particular form, and the particular couple who is looking for divorce, they have to fill this form and they have to answer the questions from a particular range, maybe 0 to 5, and these are the questions. See if you write 9, I enjoy traveling with my wife. Okay, is it correct? So you can have, if he's not enjoying, you will have 1, and if he's enjoying much, so 3, 4, 5 something, based on the scale he has to provide it. So total 54 questions are there. Okay, these 54 questions are given by the counselor, and counselor has recorded that responses. Okay, and previously the few responses are recorded, and whether the divorce was happened between that couple or not, that data set is created here. Okay, so 54 inputs are there and one output variable we are having. See the data set. There are the 54 inputs, attributes are given, and a particular couple has given these answers in this format. So 0, 1, 2, 3, 4, 5, 0 to 4, I think this values are given to these questions, and finally we have seen whether the divorce was there or not. So 0 means the divorce was happened between the couple, and 1 means there was no divorce for that particular couple. Okay, so previously these entries are recorded for almost for more than 170 entries are there. Yes, 170 couples entry are recorded. Some divorced entries and some non-divorced entries are there. Okay, so now my task is, when next couple, a new couple is looking for the counselor, counselor will fill a form and counselor can predict whether the couple will have a divorce in future or not. So whether its category is 0 or 1. It's a very interesting kind of data set I have chosen for this kind of algorithm here. We'll be solving this with the help of a neural network, artificial neural network. Okay, so if you understood the data set, so let's go for reading this data. Okay, I have downloaded the data set from UCI machine learning repository. You can check the link. It's a divorce predictor data set, and the same data set is available on MITU Skillologies data repository also. So let's check. Let's go for implementation of this algorithm with the help of artificial neural network. Okay, so let's do the prediction of divorce, whether divorce will happen or not. So import pandas and numpy. Okay, so let's open the divorce predictor. So one important thing to mention here is that this data set, okay, I have opened that in CSV here in my LibreOffice, but it contains a separator differently. The separator is semicolon here. Okay, if I open this file and so let's go for that. Let's open this file by using my editor. So see this. A separate mechanism I need to apply. Check it. So it's separated by a semicolon. So what to do in that case? So I'm having facility with me. I can change the separator while reading the file. So pd.read_csv divorce.csv and separator is semicolon. So if other separators are available, so you just make sure that we can use this parameter scp semicolon. Okay, or any other tab or new line, something like that. Okay, so data.head, check it. So first 5 entries, total 55 columns are present. Last column is a class, that is 0 or 1. Okay, now let's use class in, sorry, just drop the class and keep remaining 54 in X. Okay, and class I'm taking in Y. So class variable will be in Y. There we can check whether only 2 classes are present or not. So by using set of Y, you can check it. Even you can visualize also what's the frequency of 0 and what's the frequency of 1 by using Seaborn's count plot function. So that we have already seen in the previous some of the examples. So you can try it here also. Okay, so we'll primarily focus on implementation of the classifier system on artificial neural network. So let's use train test split and split your data like this. Okay, so I imported a train test split, then x train, x test, y train, y test equal to train test split x, y, and random state I am keeping 0. Default training size also is kept as 25%, so testing size, and 25% to training. So you see the length 170 entries, and training will be available with 127 entries to this. That's it. So pre-applications or data operations are done over here, and now we are going to apply the neural network. So let's see how to apply that. So in the sklearn's neural network package, sub package, we are having multi-layer perceptron classifier, MLP classifier. That MLP classifier uses the architecture of artificial neural network. With the help of that, the the classifier of ANN is created. So that is MLP classifier. So let's read this. Yes, let's read. And now most important thing, to create the object of this classifier. So CLF is the object, MLP classifier. Okay, it contains 2 most important parameter here. These 2 parameters are hidden layer sizes. See, input layers and output layers are defined by the architecture there. See, input layers I am having almost 54 because 54 inputs are present. Output layers are 2 because 2 possibilities are there in the output, that is 0 and 1. But what about the hidden layers? So in hidden layers I will be having 3 hidden layers which contains 10 neurons in it, perceptron in it. Okay, 10 perceptrons. So 10 in first hidden layer, 10 in second hidden layer, and 10 in third hidden layer. That's what I am mentioning here, hidden layer sizes in the form of a tuple. Second parameter is max iteration. So very interesting again. Max iteration is the parameter which is called as epochs. So one phase of feed forward and back propagation is called as the epochs. So epochs are mentioned with the help of the keyword argument called as max iterations. Max iterations I have given 300 here. So now 300 epochs, and total 5 layers. Out of this, 1 hidden, 1 out, 3 hidden, 1 input, 1 output. So this contains 10 nodes, 10 nodes, and 10 nodes. Done. Let's create the classifier. And the most important part, to train the algorithm with the given data, x train, y train, and clf.fit we are using here. Let's try it. Yes, it's fitted. And most important, here I am using activation function as ReLU. Along with that, we more like a tanh or step function, sigmoid function, they are also available here. Number of iterations also we have changed. We have changed hidden layer sizes here like this, and we have changed the max iteration also 300. They are the main parameter which are changed, and our neural network has formed. And now most important thing, to do the predictions on the remaining data. So ypred equal to classifier.predict on x test. So remaining test data I have applied, I am going to do the predictions, and now let's see how accurately this particular classifier can classify this data. So sklearn.metrics, import accuracy score, confusion matrix. Okay, that's I am importing from there. From sklearn.metrics, import classification report. So 1 to 3 different functions I imported from metrics. Let's see the first confusion matrix. Yes, so this is my output. So 20 plus 20, 40 out of 43 are matching. Yes, that's great classification. Maybe about 90% accuracy we have achieved. So in class 0, 22 are there, out of that 20 are matching, and in class 1, that is divorced, we are having 21 out of that 20 are matching. So 20 plus 20, yeah. So it's very perfectly almost classifying the system. Just check the accuracy score, 93.02% accuracy we have achieved with the help of this artificial neural network, that is MLP classifier. And if you see the classification report, now check this, yeah, 93% overall accuracy is there, and we have the recall of 91% for class 0 and 95% for class 1 perfectly. Okay, that's what we have achieved here. Now out of 43, 22 are 0, 21 is 1, and we are getting better accuracy for this data set perfectly. So this is how we are going to make use of the artificial neural network to perform the classification system. So classification system will perfectly work with MLP classifier. And remember one more thing, that MLP, that is multi-layer perceptron, internally contains the regressor also. So if you want to apply the regressor algorithm when you want to generate the output in the form of continuous values, that time MLP regressor can also be used. Now here also we can make the prediction of single entry, but 54 columns are there, so just 54 columns are very difficult to use it there. So when next time we are going to do the predictions, we have to take all the inputs, embed them in the NumPy array or a list, and then use prediction and predict it whether the particular couple will have the divorce in future or not. Okay, so this is how this classifier will work for us. Many things which I explained I have shown in the presentations also. Just try by your own. You can try this algorithm to other data sets also, which we have seen previously. Maybe we'll have higher amount of accuracy than the previous data. Somewhere we are getting the 100% accuracy also for some of the algorithms, some of the data sets, if you train them with the help of the neural network classifiers. Okay, so you can try and check the output on different kind of the data sets with the help of artificial neural network. Thank you. Thanks a lot.